So just because, ladies and gentlemen, you see a fraction or you see a product, don't jump immediately to product and quotient rule. The power rule is a much easier rule to use than the product and the quotient rule. So don't forget what you did last night for homework. For example, if you see a single monomial in the denominator of a fraction, it's easier to split it up into smaller fractions and use your power rule versus using your quotient rule. I mean, you could use the quotient rule if you wanted to, but trust me, it'll be easier to break it up. Also, with a product, sometimes it's easier to go ahead and actually multiply, distribute, and then use your power rule and find the derivative term by term. So, for example, if you see a problem like this, square root of x times x squared plus 2. Yes, it is a product. So I could use my product rule, but since this is just a single term of square root of x, it's going to be just as easy or easier to take x to the 1/2 and distribute it into x squared plus 2. So when I distribute, x to the 1/2 times x squared will give me a what? An x to the what? Well, 1/2 plus 2 is 5/2 plus 2x to the 1/2. Now you can just go ahead and apply your power rule. So then my f prime of x, what's the derivative of x to the 5/2? That's going to be 5/2 x to the 3/2, subtract your 1, plus, move the 1/2 out, 1/2 times 2x, again you're subtracting 1 from the exponent, that'll give me x to the negative 1/2. So then my derivative will be 5/2 x to the 3/2 plus 1 over x to the 1/2. So could I have used product rule if I wanted to? Yes. But this is a case where it'd be easier just to distribute that x to the 1/2 and then apply your power rule. Okay. So like I said, for a lot of these you can use more than one rule to come up with the derivatives. The question is, which is going to be the path that's the easiest? Okay. Look at B. You have x plus 1 divided by square root of x. You have a single monomial. You could use quotient rule if you really wanted to, but it would be much easier to take this larger fraction and split it into smaller fractions. So take your square root of x and divide it out. So take x and divide it by x to the 1/2 plus 1 over x to the 1/2. Again, if you have a single monomial, this is the path to take. It'll make your life easier than using that quotient rule. Now look at your properties of exponents. What is x divided by x to the 1/2? What's that going to leave you with? Simplify this. X to the 1/2. Again, you cannot take the derivative with that x in the denominator using your power rule. Rewrite it with a negative exponent. That'll give you x to the negative 1/2. So now I can find the derivative. The derivative of x to the 1/2 is 1/2. X to the what? 1/2 minus 1 will give you a what? Negative 1/2. Using your power rule now to differentiate x to the negative 1/2, that'll give me minus 1/2. X to the what power when I subtract 1? That'll give me negative 3/2. So clean this up. 1 over 2x to the 1/2 minus 1 over 2x to the 3/2. Now, I want to go over some simplifying with you. Could I actually combine this into one single fraction as my answer? How do you add and subtract fractions together? You need a what? Common denominator. What is the common denominator going to be here? 2x to the what power? Is it 1/2 or 3/2? Not 1/2. 3/2. It's 2x to the 3/2. So you have an x, you already have a 2x to the 3/2 on the bottom of this fraction. How would I have to rewrite this denominator? What would I have to multiply it by to give me an x to the 3/2 down here? I have to multiply by what? X to the what? Well, I have to, when I multiply, remember I add exponents. So what will I have to multiply x to the 1/2 by to give me an x to the 3/2 and x to the what? 1. So then I'm going to have x over 2x to the 3/2 minus 1 over 2x to the 3/2. Now that my denominator is the same, I can condense this to a single fraction, x minus 1 over 2x to the 3/2. You need to be able to look at your answers now and look at them in various forms. Because what happens, if you're looking at a multiple choice test, yes, this answer right here is correct. This 1 over 2x to the 1/2 minus 1 over 2x to the 3/2. If it's a free response question, I'm fine with leave alone. You don't have to do this. But on a multiple choice, 9 times out of 10, those answers are going to be simplified all the way. So you're going to need to be able to algebraically manipulate your answer and simplify it all the way. All right? Any questions on that? So now look at C. You agree with me that we have a product. It's 4 times this particular... Yeah, Kevin.
So like if on a free response and we did it using the quotient rule, would it be wrong or would it not?
No, your answer would look more like this, a single fraction. No, you could use either. But again, what you want to do is you want to kind of narrow that window of where you can make algebraic errors. So what happens is the quotient rule is not the prettiest of all rules to be using. So you're opening your window up to possibly making more mistakes versus just using the power rule where it's a much simpler rule to use. So that's why if you can identify what the simpler path is, you can hopefully narrow the window where you can make a careless mistake. Okay? But no, you should get the same answer if you did decide to use the quotient rule. Look at C. So we do have a product of 4 times the binomial. Again, I would not use product rule. All you need to do is, again, you can leave out the 4 and find the derivative of t squared minus t to the negative third. Get that t to the third out of the denominator. Remember, the 4 is a constant. You could distribute the 4 now, or you could wait, find the derivative of t squared, find the derivative of t to the negative third, then distribute. So how you handle the 4 is up to you. So go ahead and find the derivative of s of t for me.